friends, in this video we will study that how the memory chips can be interfaced with the 8085 microprocessor. So let's start with our topic. Before starting with our topic, let us first understand the meaning of the word interface. Interface means it is a path of communication between two components. So whenever two components they want to communicate with each other, then the path which is providing the communication, that path is called the interface. So interfacing, it is a type of technique for communication between the microprocessor and the memory chip. So this interfacing technique, it is used for the communication between the microprocessor and the memory. So through this interfaced circuit, the microprocessor and memory, they are communicating with each other. Now what's the need of this interfacing? When the microprocessor is performing the functions like it is executing an instruction, the microprocessor, it needs to access the memory for reading or writing the data or for reading the instruction codes which are written in the memory. So when the microprocessor it is executing the instructions, it needs to access the data from the memory, and to access that data it needs to read or write the data from the memory. So some path should be available for the flow of data between the memory and the microprocessor, and this path it is provided by the interfacing circuit between the memory and the 8085 microprocessor. So the interfacing it is need for the flow of data or for the transfer of data, or whenever the microprocessor it wants to read or write the data from the memory, then it needs the interfacing circuit. Also the programs which the programmer or the manufacturer has written in the memory of the microprocessor, so that programs also the microprocessor needs to execute the instruction, it needs to execute the intermediate results or the data, all are stored in the memory of the microprocessor. So whenever microprocessor wants to utilize that data, it needs to access the memory and it needs the interfacing circuit. So for interfacing or for the communication between the microprocessor and the memory, both memory and microprocessor they will require some signals so that they can read and write into the registers. Okay, so there is a need of some signals, and these signals will provide the communication, or they will allow the communication between the microprocessor and memory. So our first requirement of an interfacing circuit, it is the signals of the memory and the microprocessor. So the interfacing process, it should need to match the requirements of the memory and the microprocessor signals, so that when the requirements of memory and the microprocessor signals they are satisfied, then only the communication will takes place. So the interfacing circuits, they should be designed so that they should match the requirements of the memory and the microprocessor signals. Both requirements should be matched. Now we will first start the interfacing of the memory chips with the 8085 microprocessor. Now in 8085, we know that it has 16 address lines, which are starting from A0 to A15. And these 16 address lines, if we take 2 raised to the power 16, it will come out to be 65536 bits, or we can say it will come out to be 64 kilobytes memory. So we can say that these 16 address lines of the 8085 microprocessor, they can address 64 kilobytes of the memory. It is the maximum limit of the addressing power of the 8085, because it has 16 address lines. So 16 address lines means 65536 bits, and 1 bit, it is equal to 1 memory cell. So one data bit will be stored at one memory location. Okay, so the total memory we have, this 8085 have, it is 64 kilobytes. So this 64 kilobytes, it is the maximum limit of memory chip which can be interfaced with the 8085 microprocessor. So this 64 kilobytes memory, if we if we mark the addresses, then it will start from 0000H to FFFFH. So these will be the addresses of the memory locations which can be addressed by this 8085 microprocessor. Because it has 16 address lines, so 2 raised to the power 16, so we will have the address range starting from 000H to FFFH. So this is the address range or the addresses of the memory locations. Now, as we have studied, as I have told, that whenever the microprocessor and the memory, they interfaced with each other, then some signals are required for this interfacing. So whenever this communication takes place, then 8085 microprocessor, it uses the signals These are the 3 control signals which are used by 8085 for the interfacing. First is the input output or memory signal. This is read signal and this is write signal. This signal input output slash M bar, it denotes that whether the operation which is performed by 8085, it is an input output operation or it's a memory operation. When the value of this signal it is 1, then this will be an input output operation. When the signal is low, that means its value is 0, it means it will be a memory operation, because on M we have a bar. So it means that this will be active when its value is 0 and this signal will be active when its value is 1. Now again we have this RD bar, so it's an active low signal, means it will be active when its value is 0. And this signal, it is the read signal. This signal is active. When this is active, it means that the 8085 microprocessor, it's performing the read operation. That means it is reading the data from the memory. Then we have the WR bar. It's also an active low signal, means it is active when its value is 0, and it's a write signal. So when the signal is low, means it is active, it means that the 8085 microprocessor, it is performing the write operation, means it is writing a data byte into the memory. So these three signals, they are used whenever the microprocessor interface or it communicates with the memory. Now in response to these three signals, the memory chips, they also have some signals which are used. So memory chips, they will have these are the three signals which are used by the memory chips when they are communicating with microprocessor. First is the chip enable or chip select signal. This signal, it is used to select that memory chip. That means when this signal is low, because it's an active low signal, it's having bar over it, so it will be active when its value is 0. So when this signal is active, means its value is 0, it means that that memory chip has been enabled and that memory chip is ready for the communication with the microprocessor. If the value of this signal, it is 1, means it is not active, then that memory chip will not communicate with the microprocessor. So if we have several memory chips connected with the 8085 and the 8085, suppose 10 memory chips are connected and the microprocessor wants to communicate with the second memory chip, so it will activate the chip enable signal or the chip select signal of the memory chip number 2. So that chip, that is memory chip number 2, that will be activated and that memory chip will communicate with the microprocessor. So this signal, it is used to select the or enable the memory chip. That is why it is known as the chip enable or chip select signal. Then we have OE, that is output enable or read signal. So output enable means the output from the memory chip or that memory chip will be read from the microprocessor. That means the microprocessor, it is going to read the data byte which is there in the memory chip, and that data byte will be read by the microprocessor. So it will perform the read operation. Then we have WE bar, that is write enable or write signal. This signal, it is used to write the data byte into the memory chip. Means whenever the microprocessor, it wants to store some data byte into the memory locations or into the memory chip, then it will activate this signal, and this signal, it is going to perform the write operation. So the microprocessor, it was using the three signals, input output or memory and read and write signals, and memory chip, it will use the chip select signal, the output enable and the write enable signals while the interfacing process is being performed. Now, if we see here, what will be the value of these signals to perform the read and write operations? Let's see. If we have this input, output and memory, then we have read signal and write signal. These three signals are from the microprocessor. So if the value of this signal is 0, and read signal, it is also 0, write is 1. It means the 8085, it will read from the memory. And if this signal, it is 0, read is 1, write is 0, then 8085, it is going to write data into the memory. Okay, so means these three signals, they are deciding that whether the microprocessor, it is going to read the data from the memory, or it is going to write the data into the memory. Now these three signals, they are combined to generate two signals, MEMR and MEMW. These two signals are also active low signals, and they define the memory read and memory write operations. MEMR means memory read and MEMW means memory write. Now, how these two signals are generated? By combining these three signals. Let's see the circuit for it. So we have these three signals, input, output and read. So when these signals will combine, they are given as an input to this NAND gate, then the output will be MEMR signal, that is memory read. And when these two signals, input, output and memory plus write, they are combined, then they will generate MEMW. So this will be the memory read and this will be the memory write operation. So combination of these two signals, they are going to produce the MEMR and MEMW bar signals. This will be memory read and this is memory write. For these signals to be active, this input, output and memory, it should be 0 and its value should also be 0. Then the output will be 0. For this also, it has to be 0, write has to be 0, then MEMW bar, that will be 0 and this will be activated. Now if the value of this input, output and M bar signal, it is 1, then these two signals, they will be deactivated irrespective of the value of this read and write, because if it is 1, then the output will be 1, and here also if it is 1, then the output will be 1, and these two signals, they will be deactivated. So for the memory operation, the input, output and memory signal, its value has to be 0 because it's an active low signal. Its value should be low, that means 0. So this is how the memory chips, whenever the memory chips, they are interfaced with the microprocessor, then these signals are used. The three signals from the microprocessor and the three signals of the memory chip. So if we see the interfacing, if we represent it by a diagram, then it's a microprocessor and it's the memory chip. So what are the requirements for the interfacing? First, we will need the address lines. The address lines from A0 to A15. These address lines will be used to address the memory locations, because the memory chip, it will have registers, and to address these registers, some specific address should be assigned to each of the register locations. So these address lines will be needed to address the memory locations. Then we will need the data bus starting from A0 to A7, because it has 8085, it has 8-bit data bus, and this data bus is bidirectional. So whenever 8085 it want to read some data from the memory chip, or it wants to write the data, it can use this data bus. Then it will need the control bus also, because control bus will provide the timing and control signals. The signals like input, output, memory and read, write, these are all the control signals. So those control signals are provided by the control bus. Now memory chip, it will have the chip select signal, and it will have the output enable signal also, and it will have the write enable signal also. Here we will have input, output and memory signal, then here read and write. So this is how the interfacing is done between a memory chip and a 8085. First we will have the address. So we will define the address locations for the memory chip using the size of the memory which is given to us. Then we will have the data bus and then control bus and these signals. Okay. So in this video we studied that how the memory chips, they are interfaced with the 8085 microprocessor, which signals are used, and how the value of the signals or the status of the signal defines the operation which is performed by the microprocessor with the memory. So I hope that this topic is clear to you. Thank you.